Okay, guys, welcome back. Today we start with a new programming language, the last one. We need to talk about Prolog and the logic paradigm. Quick reminder, you have homework. Please do not forget to complete and submit your quiz and your assignment about Lisp. It's due this week. Moreover, by the end of the week, we are going to open a new quiz and a new assignment because, well, hopefully we finish this week with Prolog. Therefore, you have a week to work with the Prolog assignment. And with that, we're going to finish. After that, we do a review and then your final exam. Remember, final exam, 25% is a good amount of points. So start working, start preparing yourself for the final. Comprehensive, again, C, C++, and everything that we review about Lisp and the things that we're going to review about Prolog. So review things, and any question, please let us know. Good. Prolog. For Prolog, the first thing that I want to do is to check the logic programming paradigm. This is the language that we're going to review, and as with the others, the goal is not for you to be experts in the language. You are not experts in Lisp or in C, C++. It's only about knowing the paradigm, and the language is our tool to know, to check, to review the features of the different paradigms. For the logic paradigm, if you remember, our picture is, well, we finish with this, the oldest of the languages that we're reviewing. We take some time here, and here. And now the last one, finally, this guy. The first thing that I want you to notice is this guy, this particular paradigm is mostly about this language. That is the language that represents the paradigm. The 70s. And you look to the column and it's almost empty. Moreover, it's not connected with the others that we review. It's something that is going to be particularly different. Not only different from C, C++, Java, Lisp, but different from the other approaches that we have reviewed about programming. Lisp was different, but in some points, the big difference was the syntaxes, the semantic, but the elements were very familiar. We still were working about, well, methods, variables, conditions, loops, data structures. We basically reviewed those key elements in all the previous 4 programming languages. Those are the key elements in all of them, in everything that you have reviewed so far. If you review Java 9, somehow this guy here is connecting with ideas that we review here. Functional programming, some features at least, are going into object-oriented paradigms, lambdas. Anyway, but this is going to be a different thing. Why? Well, it's going to be a different thing because one key idea that we review in the lecture 2, the key idea for the logic paradigm is I do not want to do programming. I need to ask the computer to do something, but I do not want to do programming in a traditional way. I do not want to talk about loops or conditions. I do not want to deal about that. I do not want to talk about data types. I do not want to talk about variables at all. What I want here, the idea for the logic approach, you know what? I have information. And I want the computer to help me to work with this information and to infer new information, to get data from the data. Data, the computer processes the data, the computer gives you data from the data. And what I want to do is to have a conversation with the computer. Computer, here is the data. Computer, what can you tell me about the data? If this student get an 80 in the exam, computer, do you think that this student is going to pass the class? Yes or no? Here is the data. Here is all the grades, all the homeworks, all the quizzes. Is going to pass or no? I do not want to create an if-else condition. I do not want to do an iteration of all the rows in the list of students. I just want to, here is the data in whatever presentation the data exists, and I want to start asking questions. And if you're thinking about that looks like a database, you are correct. The approach here is one approach that is more familiar to database systems, to structured data handling than with programming. However, Prolog is a language. We're going to review the language. Databases. As always, we need fancy names for things. Fancy names. You know what? Information. Instead of talking about information in Prolog, we're going to talk about facts, and we're going to talk about rules. That is our information in Prolog. Think about, you have a database, kind of, the computer, an interpreter. And the first thing that we're going to do is to provide information to the interpreter. And that information is going to be two things: facts, statements, and rules. There are going to be instructions in the language to give the interpreter facts. There are going to be instructions in the language to give the interpreter rules. You provide that, you insert that into the interpreter, and later you can ask questions. Ask questions, a fancy name. You can do queries. Queries, yeah. Just like a query in a database, you can ask things. But these things, if you compare Prolog versus something like SQL, here you create the query in order to get the information that you want. Here, the idea is a little bit more like artificial intelligence, quotation marks, a little bit more like an open question, and computer, help me to find answers for these open questions. We're going to review examples, don't worry, but the important thing here is logic programming paradigm. Prolog is closest to what we know as a database system. We are going to insert information to the system, to the interpreter. That information is going to be facts and rules. We're going to review the difference between them. And then we're going to be able to ask questions. Those questions are going to be called queries. Facts, rules, and queries, the three things that we're going to be doing with Prolog. And no programming means no data types, no variables, no loops, no functions, no conditions. All of those elements that so far we review here are going to be missing, most of them. Okay, so big picture. The next question that you have is, okay, what I need to do in order to, number one, get access to the system, install the system. Number two, I have the system running, what I do to put these things inside. And finally, what I do to ask this and therefore get this. What I do for every single step here. Okay, let's start with number one. Global review here. Important things. The fancy name for our interpreter is a deductive database. We're going to call it an interpreter. We do not have a compiler here. We're going to call it the Prolog interpreter, just like we did with the interpreter in Java, just like we did with the interpreter in Lisp. In this case, every single time that we talk about the interpreter, we're talking about this deductive database. Our interpreter is our handler for this deductive database. Deductive, yeah, because it's going to have information and it's going to infer new information from that. We're going to review it. Now, important thing, we're going to install this. We're going to install the interpreter, and when we install the interpreter, we're going to have this deductive database. The database is the interpreter. Number one, we need to install that in our systems. We can install one locally, or as we did before, we can access the interpreter for Prolog online. What we're going to access is this interpreter running in a server, this deductive database running in a server. The only thing that we do is to send requests, send facts, send rules. That database is going to store that, and later we can ask queries. That database is going to send us back the answer using the browser. You can install one local, or you can use the online. Both options work. My advice, you can use the online. Don't worry to install things in your computer. You don't need to do that. It is not mandatory. Anyway, important things for the step 2. Important things for the fact, the rules, and the queries. Something that I want you to notice here. Uppercases, lower cases. Every single thing that you put in a lowercase is going to be information. Every single time that you want to specify a fact, every single time for the rules that you want to include information in a rule, everything that is information should be lowercase. Lowercase. Remember that Lisp don't care about that. C, C++, Java care about that. Well, here we care about lower cases and upper cases, but moreover, the things are going to be different. The meaning is going to be different according with its uppercase or its lowercase. If it's lowercase, is information. Information in a rule or information in a fact. If you put something in an uppercase, whatever is in uppercases, even though it's used one letter or all the letters, it doesn't matter. If you put something with a uppercase at the beginning, that something is the equivalent to a variable. We do not have variables here, but that something is this space to store information, like a variable. Every single time that you read something in uppercases, that something is a place in which information is going to be provided. Again, that something is like a variable. And we're going to have these places when we create queries, because if we ask for something, we need a place to receive the answer. We need a variable to store the answer. Think about this like calling a method, and the method returns something. You need a variable to make variable equal the method. So the information that the methods return back, you put that information in some place. That some place is going to be these variables, quotation marks, these places that are going to have as a name something with uppercase. Uppercase, variables. Lower cases, information. Remember that, it's going to be very, very important. And this rule is true for queries, rules, and facts. Uppercase and lowercase here are different. Okay, so the database, we need to have access to that. And in the database, we're going to do insert information and do queries. To insert information, most of the information, lower cases, and when we run queries and we need to store the result back, we need something in uppercase that is kind of the variable name. Okay, Number one, the interpreter, the tools, Prolog, as usual. Option number one, you can go online. That is the link, is a web page. In the web page, you have something like this. And basically, these are the elements. Whatever you put here is the information, the facts, and the rules. These instructions are to insert data in the database. This first column in the online version is the column in which you put whatever you want the computer to know, the information that you are sharing with the system. Facts and rules, we're going to review them in detail. But here, the first column is the column for adding information. By the way, hopefully you notice this symbol here in the line number one is something like this, percentage and something. What do you think is the percentage symbol in Prolog? Used because the color in this picture. Correct. Comments in Prolog begin with the percentage symbol. In Java, with the semicolon. C, C++, and Java, you remember the diagonals. Percentage, comments. You can use comments, just like in any other language, in any place, and whatever is after the percentage is going to be ignored. It's a comment. You already know about it. But well, facts and rules, the informations in the first column. Then here in the lower part of the second column, this is the place for doing the queries. This is the place in which you can ask something to the computer. Obviously, it's a database. Step number one, provide information. Step number two, ask questions related with that information. If you ask a query, but you do not provide information, well, the database is empty. All the answers are going to be, I do not know, I do not know. I am going to show you what is the equivalent to I do not know, but put information, add the queries. And then this, the upper part of the second column, the one with the logo, here you are going to get your answers. In the online version, data, queries, answers, just like this loop, 3 different parts. Most of the examples that I am going to show you run here. My recommendation, you can copy paste the code, go here and test it. What I am going to do for the slides regarding Prolog is I need to be very, very clear about what is information, therefore what you need to put here, and which are the questions, therefore what can you put here. So be careful when we review some examples, when we're talking about facts and rules, therefore should be here, or we're talking about a query and therefore it should be here. Important, as you can notice here, I do not know what is this yet. I mean, what is the particular meaning, but everything lowercase. The comment obviously doesn't matter. In the comment, you can use lowercase, uppercase. If you use a comment, it's going to be ignored. But in the line 2, what you have there is your first instruction in Prolog. We're going to review that. But father, me, Sarah, that is information, all lowercase. Here, you have something that is very, very similar. Don't worry, we're going to review that. The only thing that I want you to notice is there is an X, and that X is uppercase. That X is a variable. That X is a place in which I am going to get back an answer. Moreover, if you notice here, in the answer part, the system is going to tell me, oh, that X is equal to something. The X is the variable, the question that I ask. And the value for that variable, the information that I am getting back, is the one in lowercase. Uppercase, variable, lowercase, information. When I receive an answer, usually it's going to be in this format, variable equal value, variable, your question, value, my answer to your question. That is the idea. Now, this is very nice in the online because have this graphical user interface. What happened in the local? What happened if you run a local interpreter, a local database? Probably there are different versions. The one that I found, the one that I shared with you in a previous lecture when we review all the interpreters options. Very good thing. Let me go back here. You notice that we have a dot here and a dot here. The dot in Prolog is going to be the equivalent to your semicolon in Java, C, C++. Is the end of something. In this case, the end of a fact, the end of a rule, or the end of a question. That is, yes, the delimiter for finishing an instruction, fact, rule, or query, the dot, the replacement for the semicolon. Good. If you use the online graphical user interface, if you want to have something in your local computer, usually the local versions are going to be like the following. You're going to open a console, and in the console, well, it is the same console, but you need to change from providing data to asking questions. It's like in the same console, you need to access the insert mode or access the query mode. You change that in the console with a particular instruction. When you put that instruction in the console, I am talking about the console of the interpreter, you are able to provide information. Whatever you put is going to be handled as a fact or as a rule. You are in the console, you write user dot enter, and then you continue in the console. Whatever thing you write, enter, write, enter, write, enter, are things that the computer is going to be storing. The computer is just reading and storing the data. In some point, you go out of that mode, Control C, you are back in the original one. And then when you are back in the original one, whatever you put there, you are going to notice that you're back in the original because your prompt is going to be this. That is kind of the prompt of the system. Just like when you are in the console of Windows, you have this prompt. It's not something that you need to write, it's something that is there. You start writing here. So in Prolog, this is your prompt. Is the question mark, the minus, and here you can write things. When you have this prompt, this symbol means that you can start writing, and what you're going to write is a question, a query. So user dot, your prompt is going to change, and you can input data, facts, and rule. Control C, you're back to the question mode with this prompt, and whatever you write is going to be a question, and the system is going to start trying to answer your question. And in some point, you're going to have an answer. Your answer is going to be something like variable equal value, and that's it. This console mode is a little bit tricky. I really do not recommend this if you are not familiar with using the console. If you are, great, you can go ahead. But for learning purposes, I am going to be making references to this just because you can have everything on the screen. The information, the queries, the results, so you can follow and debug your programs if you need it. It's an interpreter online, or you can explore the local, up to you. Good. So, number one, my system, my database. Number two, what you want to do, start learning the language. What is this? What is this? What is happening there? What can I do with this language? Moving forward, basics of Prolog. Let's see. Number one, in Prolog, every single line is what we call a predicate. every single line in Prolog is going to be a predicate. Moreover, it's going to have the following syntax: the name of the predicate, parentheses are back, and inside, separated by commas, what we're going to call the arguments for that predicate. Okay, the first question is, what is a predicate? Predicates. We're going to call predicates any kind of relationship. Relationship between data. And these parameters are the data. Prolog. Give me data, moreover, tell me how that data is connected. Relationship between the data, predicates. Any kind of relationship. As you are going to notice here in this language, the most important thing are the relationships. The most important things are the predicates, and they go first in any single line. The data itself is used like arguments for the predicate. Okay, predicate, parameters, relationship, parentheses, data. That is the key element, the most important element in Prolog. And at the end, every single predicate, every single line is going to end with a dot. Predicate, parentheses, data, parentheses, the dot. Looks simple, right? The syntaxis at least is simple. No data types. Examples, trivial things. You know what? I want to tell that someone in English, John is the father of. This kind of sentence in English can be translated to Prolog. In fact, the main idea of Prolog is to put whatever you can tell me in English, but with a different syntaxes, the syntaxes of the language. This line was the example that I showed you before. What is the data? Well, the data here is John, whatever a John is, and the information here is Jane. The computer do not need to know that those are names of people or something else. Is something with the name John, is something else with the name Jane, whatever that something is. But those two concepts, those two items are connected. There is a relationship between them. The relationship between them is one is the father of the other. And I am talking not about inheritance and classes and so on. I am talking about people, real people. I am telling the computer, hey, there is these two items, two persons, and they are related. And the name of the relationship is father. I do not need to explain to the computer what is the meaning of that. The only thing that I need to tell is there is a relationship with that name, whatever it is. Any single sentence in English, any single fact can be expressed in this way if that fact is expressing information and relationships between that information. For instance, this one, this one, this one, this one, all of those four, they are facts. And hopefully now you get the idea of the following. The predicate, the relationship, is what usually in English, the verb, the action. Father, well, is the father. likes, travel, something else. And the items inside, usually they are going to be nouns. Personal nouns, items, people, whatever, the things that are connected with the verb. When I tell the computer that there is a relationship like likes between Bill and car, in English, Bill likes cars. Bill, someone, something, likes bikes. That same item, that same note, travels by car. The same one travels by bike. Did you notice that basically we remove all these words, is, the, by, all the words that complete the sentence are not there. But the key elements, the items, the nouns, moreover, the relationships, they are there. I have 4 facts here about one item, one people, Bill. And basically now I have 4 relationships between this item and other things. What this person likes and what this person uses to travel. It's kind of a graph database. It's this database in which you have an item and all the connections of that item with other items that could be other people or other objects, and what is the name of that relationship. You can imagine like the database in your Facebook. You are the central node, and there are relationships, connections with your friends, other people, but also with items or topics or movies or whatever that you like, literally like, because you click the okay thing. It's a graph, relationships. That is the information that you are providing. The name for that information for each of these small items, facts. Okay. Now, you can put together facts. You can combine facts. And you can combine them in 2 ways. You can use and, or you can use or. Something and something, and you can continue. Something or something, and you can continue. In Prolog, the and is going to be represented by the comma. Every single time that you put a comma, you are telling and. Or, if you want to say or, you can use the semicolon. For instance, here I have 2 facts in one line. And what I am telling is, you know what? This Bill likes cars and Bill likes bikes. They like both. In the second example, this Bill travels using a car, or he also travels using a bike. In the second example, the or is because it's one or the other. You do not travel using both at the same time. So it's more like you are traveling using one or the other. You represent that here. The computer needs to know that level of specificity because that is the one that is going to use to answer your questions later. So, and, or, and individual facts. Individual facts, they have a name, usually a verb, parentheses, and they have nouns, the nodes that are connected. In a graph, these here are the nodes, and this here is the name for the connection between the nodes. The connection first, and then inside of the parentheses, the nodes. And you can imagine that you're going to create a network of information with connections. And that is the network that the computer is going to use to answer your questions. Now, moving forward, these are the facts. We need to talk about the rules. Rules are like this. Rules have two parts. Something, and then colon minus something. The meaning for this is if. If. Not the if like in the other languages, like one condition controls the execution of something. This is an if like a sentence. Something is true if something else is true. Is the if that you use to share information and to establish that something is going to happen if some kind of condition also happen. You are going to get an A+ in this class if your final grade is above 97. I am not running a program like an if condition in Java. I am sharing information with you. The information as a rule. A rule. Something that have a condition is called a rule. A rule. You are going to get an A+ in the class. That is a fact. But then I put the condition. If your grade is greater than or equal to 97. A rule is this combination of facts in which one is the condition, the other is the consequence. In my example here, even though it's trivial, we're going to notice the use of this later, but Bill is the father of Joy, and you're noticing the order for the reading. You start at the center, move to the left, and then continue to the right. Bill is the father of Joy if Joy is the son of Bill. You are playing? Yeah, I am playing, but it's just example. For the humans, looks like this is trivial information. For the computer, this is important. For the computer, what I am telling the computer is, you know what? You are going to have these two elements. And between those two elements, if I start talking X to Y, and if I told you that the relationship between X and Y is father, also, if you connect the relationship but in the opposite direction, what you have is son. In a conversation, if we start talking about this or about this, we can start looking for, okay, this one is the father of who? Oh, the other one. You are talking about the son of this one. Infer conclusions. We're going to work more about it, but this is the reason of these kind of trivial things. Give information to the computer. The computer is not smart. The computer needs to know the details. The computer needs these kind of clarifications. Sorry. But more of this that I provide to the computer, better questions that I can ask later. Anyway, syntaxes, predicate, parentheses, information with the commas, at the end, a dot, and you are done with the fact, or comma or semicolon, and you can continue making the fact greater with ors and ands. Moreover, if some fact have a condition, that fact is called a rule. And you're going to notice that because of this symbol. So in terms of the language, what you have is everything in Prolog are facts, and you have a particular group, a subset of facts that are called rules, those that have conditions. Rules and facts. The one with the conditions, the one without the conditions. All of them finish with a dot. That's what we have there. Okay, looks simple, right? Hopefully. Moving forward, things for you to know. Classical questions in your exam, just to be sure that this is clear. Natural language, sentence in English. And the question is, they are facts or they are rules? That should be easy. The only way that something is a rule is if you have if. These three are rules. There are conditions there. All the others, they are just facts, no conditional things. Okay, that was easy. You search for the if or something similar. I am going to be using if in my examples, but if we have the if, that is a rule, or that should be a rule. If you do not have the if, those is just information. Information, can we translate from this to Prolog? Well, the only thing that we need to do is to identify the verb, the relationship, and the information. A car is fast. Hopefully you can agree here that the action, the verb, the relationship, fast. That is the relationship, that is the predicate, that is the verb. Well, the verb is, but didn't give us any particularity, is whatever. So we use fast, or you can put the relationship like is fast, it's okay. Fast, it's up to you, it's your program, it's your identifier. Usually you are going to notice that instead of using is, that is too generic, we put fast, and we assume that for all these words that are not verbs, the verb itself is, be. Inside of the parentheses, the information. What are we talking about? Cars, a particular car. Fast, parentheses, car, the dot. And the dot, because it's the same dot that we use in the sentence in the natural language. One sentence finished with a dot. In Prolog, it's the same. A rose is red. The action is red or use red. And the object, the rose. Okay, going back to my example with this Bill. Bill likes the car if the car is fast. That is a rule. It have an if. In Prolog, the verb likes, the verb is fast. Two facts, one before the condition, the other after the condition. Before the conditions, likes. Two elements, Bill and car. Remember, the reading is going to start here, it's going to move here, and from here it's going to go here. So you can figure out that, okay, we're going to talk about Bill, that is the first parameter. And then we're going to talk about the action, likes, and then we're going to talk about which is the item, like it. Likes, Bill, comma, car, if, the if, and then another fact, the action, the verb, the relationship in the second sentence is fast, can be okay. And inside of the parentheses, the noun, the subject. What are we talking about? The car. Be like cars if the car is fast. Natural language, Prolog. The next one. Hopefully you can follow me with is high, is the action. What are we talking about? Humidity. We can be talking about people. We can be talking about objects, or we can be talking about intangible things. It doesn't matter. They are the parameter. And before them, the relationship, an action, a predicate. Humidity is high if and notice this sentence. Can you agree with me that there you have this, it rains? What you have there is the verb, raining, but you do not have a particular noun. I mean, you have an action, but you do not have someone or something doing that action. The only thing that you know is the action is happening. You have the action, you have the predicate. Open parenthesis, inside of the parenthesis, empty. The action is happening. It's just happening, it's raining. No one in particular is raining. We're not talking about this particular car is doing something, that particular person is doing something. We're talking about this thing is happening, nothing inside, but there is a predicate. Just like the English, right? Nothing in particular, not subject, but an action. Going back with the family relationships, Jane is mother of Elaine. You notice here the upper cases in English because we're using names. When you translate, you can use mother. You can use is mother of, is mother. You can put all the characters together. You can use the underscore. Up to you. It's the name of the relationship. It's like the name of your method. It's just an ID. Mother of, parentheses. And because I am going to start reading here and then move here, the two objects that are connected, Jane, mother of, Elaine, or whatever names you want to use. Jane, mother of Mike. If you have a mother, you have someone that have two kids. For each of the kids, you establish a relationship. So for each of the kids, we have mother of, the same initial node, one child, the other child. That is going to create this node with two connections. This one is the mother of this one and the mother of this one. That is what the database is going to know. Later, any of these are going to be pointing to this, like the mother, or we're going to be able to count how many childs this node have, how many sons. Father, relationship, father, relationship. And in some point, you can establish things a little bit more complicated, a little bit more elaborated. Think about this. You're trying to explain to someone what is the meaning of a grandmother. Try to explain that to another people. And you're going to tell that other people, well, we call grandmother that relationship between two items. This item, this person is the grandmother of this person if you establish a condition, but that condition is going to be a little bit complicated. It's not going to be just yes or no. It's going to be a sequence of events. So something that you can do in Prolog, and you will do the same in writing English, is, well, establish parentheses just to tell, hey, I am going to give you a condition, but this condition is kind of elaborated, complicated, have several different elements. So let me open here parentheses so I can mention everything. And the condition is something like, well, you know what? This X is the grandmother of this C. Notice that I am using uppercases. I am using these variables. I do not want to mention a particular name. I do not want to mention Mary is the name of the grandmother and John is the name of the child. I want to establish a rule that works for everything. And usually when we talk, we will talk about X and Y. And X is everything, Y is everything. In Prolog, you can use uppercases. It could be X and Y, or it can be X and C, or it can be whatever you want, but in uppercase. And that uppercase represents something like whatever, anyone, whoever, a variable, a space that you can fill with any name. It doesn't matter. You can put rules or facts in any order. It's just you are providing all this information to the computer. Doesn't matter the order, don't worry. I am going to put this inside of the Prolog interpreter, but first I need to be sure that we can write these things and we know what is happening here. So just to finish with the example, X and C, variables, like someone, something. Someone is the grandmother of someone else, if. And here, notice what is the content of the condition. X is the mother of Y. So X is the grandmother if X is the mother of someone else. And this is "and" in English. You will notice the comma in Prolog. And this X have a relationship mother with C, or this Y have a relationship father with C. I put the picture to show you what I am telling you in English. I am trying to explain someone to the computer. What does it mean, the relationship grandmother? And I am basically explaining, you know what that relationship is? Well, this object, people, person, noun, element, item can be called the grandmother of another one if this one is connected with something here with the relationship mother. And this something here is connected with this one with either the relationship mother or father. That is your explanation in English for grandmother. And hopefully you can read this in Prolog and agree with me that that is the representation of the same rule, but to explain that to the interpreter of Prolog. Grandmother of X and C variables, whatever name they have, if mother of X and Y. Notice that I am using the same variable and I am suddenly introducing another variable, another node. I don't care who this is, but if there is a connection between X and Y and there is another connection between Y and C with mother or between Y and C with father, that is my explanation for the computer about what is the meaning of being a grandmother. Rule, 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 facts. Good? For you and your exams, another examples. I am going to use this description. Number one, all the things that I put as facts are things that you need to put in the first column. And now for the queries, I am going to use this prompt just to show you that those are queries, but please, you do not need to write this. This is something that I use as an indicator of the question, but the questions, the queries are used something like this. And when you have this icon, the meaning is these guys should be in this place if you're using the online interpreter. The facts, the one that I show you here, or the one that I have here, go into this first column. And then you can ask questions. The questions go here. And you will notice that here you have this small prompt, even in the online one, the question mark and the minus. The meaning is there you put the queries. That is the symbol for queries. So let's review queries, because all of these rules and facts. Queries. Step number one, before asking queries, I need to provide information. The easy way to provide information, facts. Facts. The simple facts that you can have is those facts that are relationship without items. Relationship without items. Yeah, those that you have with open parentheses and nothing inside, open parentheses and nothing inside, open parentheses and nothing inside. You know what? If your parentheses are empty, you can delete your parentheses. Similar idea we had before with list, right? For instance, I want to tell you the exam is easy. It's just a fact. The exam is easy. If I am going to talk about easy other things, I can talk about easy, the exam, and then I can talk about easy, the homework, and I can continue enumerating things that are easy. But I can also say, you know what? The exam is easy. Nothing else. That is my relationship. The exam is easy. No objects, no connections, use a simple, easy fact. Depending on my program, all those are correct. I can say Arizona is hot, and that could be used Arizona hot without nothing here. Or if I am going to talk about hot in other states, Arizona is hot, and I can continue. Texas is hot, whatever. July the 4th is Independence Day. Use a fact. I want to be sure that the computer knows that July the 4th is Independence Day. I can use that big name for the relationship. That's it. And I put this into the database. Step number one. Step number two, I can start asking questions. Questions. Question. 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 Or if you do easy parentheses exam dot, you can put that as a question too. Or if you put hot parentheses Arizona, you can use that as a question too. In fact, the questions are also facts. What is the difference between a fact and a query? The place in which you put that statement. If you put the statement here, you are giving information. Exam easy. Information, because it's here. Arizona hot. Information, because it's here. If you put exactly the same here, that fact, the same line, become a question just because it's in a different place. Here, hopefully you can read, exam easy, period, is a fact. I go Arizona hot, is a fact. July the 4th, Independence Day, is a fact. And then I go here to the question place, and I put July the 4th is Independence Day, dot, and if you click this rune here, what is going to happen is that the computer is going to answer the question with true. You're asking me if July the 4th is Independence Day? Yeah, that is true. Or maybe you can ask about Arizona hot, and the computer is going to answer true also. Or maybe you can ask about the exam is easy, and the computer is going to answer true also. The computer is going to return true every single time that you write here something that you already put here. Any information that you provide here, when you ask a question that is exactly that information, the computer is going to tell you, yeah, true. True because you told me that before. If you ask here for anything like easy, the quiz 1, in this example, the computer is going to tell you false. Why? Because I do not have information here about easy quiz 1. If I do not have information, false. If I have information, true. That is the only thing that this database is going to do. Make sense? So talking about the order, the only thing that you want to be sure is you need to provide here all the information that you have before start asking questions. Because if you ask a question about something that is not here, you're going to get a false. Once you put here the information that make the particular question true, you are going to receive an answer true. Having the information make the question true. If I do not have information, anything that I do not know, that Prolog do not know, is going to be false. And the only work of Prolog is to tell you true or false between sentences. Well, with that, we can create more complex things, don't worry. But so far, the beginning is facts, rules. You ask a query that is also a fact. And the only thing that I tell you is true or false, depending on whether or not I have the information. More examples, more complex facts. Again, 2 boxes, these are the facts, these are my queries. Facts, going back to the previous one. John likes Mary. Fred eat orange. John age is 32. Ian age is 2. Did you notice all this connection between data? This can be relational data. I put that here, and that is information for the computer. And then I can start asking questions. Asking questions. Question number 1, eats Fred orange? It's exactly this one. The computer is going to tell you that is true. Whatever is the meaning of oranges, or whoever is Fred, or the meaning of this eat, the computer didn't know. But you tell that that relationship is happening. When you ask, you're going to get a true. Eats Mike apples? We never talk about a Mike here. False. Age of Ian 2. And this is important. You mentioned that the age of Ian is 2, but 2 as a number. If you ask 2 as a letters, the computer is going to tell, no, you tell me that the age is 2, not 2. The computer didn't know that those things are the same. Well, you can create a rule, and the rule can say to the computer, hey, computer, if x equal 2, x equal 2 with the word also. You can create a rule to explain the computer that. And if you do that, you can make this to be true. It's going to apply the fact and the rule. But in this particular case, with only this information, the answer for this is false. You tell me a number, I have no idea that this word and that number are the same. So the information that I have is different. True, false, false. Facts and queries. Okay, so far, good. Something more complex. Besides asking for true and false, I can ask for answers. Answers like, you know what? I would like to know it's Fred, and this is a variable. And what I am doing is telling the computer, tell me any value that make this sentence true. Go to your data, go to your graph, and basically search for anything that I can put here for any value of this X, uppercase variable. Any value that I can put in that variable that make that sentence true. Anything. And if you think about it, I am asking the computer for everything that I tell before that this Fred eats. I am asking for do a loop. And inside of that loop, I am asking for do an if indirectly. That is what happened inside. But my question is, computer, eats Fred what? And the computer is going to answer me with this. You know what? X equal orange, and with that value of X, your sentence is true. And what happens if I put eats Fred apple? The computer is going to return as a result X equal orange, and also is going to give you X equal apple. It's going to give you all the values for that variable that make the sentence true. It's going to give you all the variables that I have, all the values that are connected with this node with the relationship it's. This is inference. This is searching in the data for information. This is what you can do with this kind of language. Similar way, it's another person, X. X, every single time that you put a variable, you're asking for all the possible values. Can you tell me something about what Mike eats? And the computer is going to tell you false. And that false is the answer for I do not know. I do not know. Why you do not know? Well, because I do not have any Mike here. So you are asking me for a relationship and to start in a node, but that node, I do not have it. I cannot tell you anything. In Prolog, the answer false can mean as an answer, I do not know. Moving forward, can you tell me the age of this particular person? And this is a variable. And the computer is going to tell me, well, if you put that variable with the value 2, and again, I have no idea what is 2. It's a character, it's a number, I do not know. But if you put a 2 there, that is what you told me what the age of that person. Can you tell me likes, variable? Did you notice the uppercases who? Can you tell me in this group of people who like who? Well, I can tell you that there is a relationship likes, and you tell me before that there is a John that likes a Mary. In this example, I only provide one value. I can provide more. And it's going to tell me all the subjects that likes others. And could be one or more. Think about this kind of language to process the information in a graph, like all the information that something like a social network have about you. Can you think about the instructions for tell me likes who, and as a value, ASU. Lowercase, I am using as a value. Uppercase, I am asking for values. This is a variable. Likes. As a programmer, I don't need to worry about the for loop and the variable, and for each variable make a condition and compare with something and store in a linked list or a stack in order to return that information. I only put an uppercase here and remember to use lower cases for everything else. The query, obviously I need to put information here before, and I am going to get an answer. All the work, the interpreter. That is the key idea with Prolog. Any questions so far, guys? Good? Okay, I am going to stop here. We continue next lecture. Thank you.